2:15, so should be on time. This talk is called Securing the World Together. A little bit about myself first. I work at the WatchCOM security group as a penetration tester. That means I break into stuff, or try to break into stuff for a living. What I do, I specialize in red team exercises, which is a fairly new concept of ours, where we simulate an attacker, try to break into a company, and then pass over a report telling them how we did it. We also do a lot of web application security and network security for a lot of different companies in Norway and abroad. I also have some credentials. You can see the abbreviations down there. I'm not going to tell you what they mean, but you may look them up and see if you find anything useful. They're just there for reference. So, a lot of people think that hackers look something like this. You may have seen the TV show. That's not quite true. A lot of hackers and professional penetration testers end up looking something more like this, which is not so cool. So, I work at WatchCOM. And what does WatchCOM do? We help our customers find vulnerabilities. The reason we do this is so we can help companies get more secure. And there are a lot of vulnerabilities out there. There are thousands published every year. We find vulnerabilities in web applications, mobile applications, apps, and even in company networks. And a lot of you are now developing your applications to interact with SuperOffice. And I'm sure there's going to be vulnerabilities there as well. When we have found vulnerabilities, we continue on the process and advise our customers on how to secure their web applications, their networks, and their company. We've been doing this for the past 10 years, and a lot has happened in that time. We've gone from worms, where millions of computers have been infected during the time span of days, to this day and age, where targeted attacks is more of the norm. So, for the past 2 years, WatchCOM and SuperOffice has been working closely together, doing a bunch of activities in order to maintain the security and improve the security program at SuperOffice. So, this is a subset of the activities we've been doing. Security audits. Every component at SuperOffice in the SuperOffice software sphere has gone through a security audit or will go through a security audit. This happens both continually and as sort of standalone tests where you sit down with the team and do maybe 80 hours of testing at one software product. We also do security design reviews, where we come in very early in the process, help SuperOffice to introduce security as early as possible to avoid vulnerabilities later on, making it cheaper to fix those vulnerabilities. We've also been working with network security, both internally in SuperOffice's development environment and infrastructure, but also with cloud security that's connected to network security out there in the online cloud. And this is increasingly important because, as Marek was telling you about yesterday, you need to be monitoring your cloud environment, making sure that no one is breaking into it, and actually being able to detect it if they do. So, there are a lot of components in securing the cloud environment. So, subpoints under that point would be vulnerability scanning, would be managing patches, it would be security testing, it would be adversary simulation, training to defend against an adversary. We also do security development training. We have been doing a course for SuperOffice developers where we try to help them incorporate even more or better practices of secure coding in their daily work, making them aware of the common mistakes that are made. It's easy to forget when you sit there coding every day. that you may introduce a Crosssite scripting or SQL injection, or it's easily done. So we have done training with them and brought them through our training program, and we hope that it's helped them develop more secure software. And I can also say we are working on arranging a security training program for partners as well. It's a little bit further down the line, but hopefully we can offer you that within the next half year or so. Also, we are the ones doing the partner certification audits that you've been hearing about. We certify our apps with regards to security. What does that mean? We check the security of every application. First, we send out a form containing a security evaluation. You have to fill out what your organization does with regards to this and this and this. There are many points regarding how you manage patches. Do you do vulnerability scanning? Do you test your software regularly? And so on. This gives us a pointer about your maturity as a company with regards to security. Do your developers know OWASP top 10, sort of stuff like that. We ask you all these questions and it gives us pointers about what we're going to look for. The next thing in the security certification is vulnerability scanning. That means we employ a security scanner that is aware of a bunch of known security vulnerabilities, and it looks for those vulnerabilities in your software and in your platform. Also, we like to include some of your infrastructure, your local company network where you sit and develop these applications in this scanner. Because if your development network gets compromised, your app is most likely going to get compromised, or it could. Finally, we include manual testing, both us and Margrethe, right there, of the integration itself, looking at what you do with the APIs, how you store the data that you pull from the APIs, how you employ the keys that you've gotten from SuperOffice for interacting with the APIs, and so on and so forth. So this certification process is quite simple. It's 3 steps, security-wise. And we hope to streamline this very much in the future so that we can get you through this very quickly. The result of this is a report from us outlining red flags or really bad vulnerabilities that we would like you to fix before you enter the online environment. That's only discussed between WatchCOM and you as a partner. SuperOffice only gets the result in terms of red flags. They know that you have red flags, but then we talk to you and get them fixed. So, who wants to attack you? I don't have anything interesting. That's the usual answer, right? Nobody wants to attack me. So there's 3 motivations or main motivations to an attacker that I want to discuss. Your information. I mean, we're working with CRM systems here. It's your customers' data we're protecting. And that information is valuable to a lot of attackers. Some of your customers may be dealing with large contracts that are stored in the CRM. Others may have sensitive stockbroking information that can be used to do insider trading. None of this needs to get out from that CRM system into the hands of an attacker. So that's one valuable point to the attacker. Computing power. All of you have some form of computing power at your disposal. You have your company network, you have a piece of a cloud that you're renting, or maybe you built it yourself. That is valuable to an attacker because he can use that power, if he can compromise it, to, for instance, mine Bitcoins. He could use it as a spamming platform. He could use it, as we will see later, to exploit your users, to serve attacks to them. And there are tons of uses that he can do or use, make use of your infrastructure, your computing power, to gain him an advantage. So the last point, main motivation is money. Anything that the attacker can earn money from is interesting to him, making you all sort of a target. You have computing power, you have information. Why wouldn't he attack you if he can? So I hope that makes you understand why you all are sort of a target, even though you may not be aware of it. Yes. Other examples are credit card data. Some of you guys may have to handle credit card data when you sell your apps. You've probably seen headlines where millions of credit cards, or thousands, have been on the loose and dumped to the internet or sold to black markets, and we don't want that happening to you. Okay, so who is these guys who are doing these attacks and trying to attack me and steal credit card information and information from sensitive companies that are my customers and so on? Yes, there's a bunch of names for them. And antivirus companies like Symantec and Kaspersky and all these, they like to name them. They like to name them so they can refer to them in reports. And we have names like Black Wine and Energetic Bear, APT29. All of these hacker groups do targeted attacks and steal information, dump credit cards, and so on. They also like to give them fancy logos. So, here's an example of an APT or a hacker group that has been making use of computing power of people they have hacked. What they do is that they offer a VPN service, a commercial VPN service. And for that to be effective, they need computing power. So what they do is they go out there, they target innocent companies, networks, and they hack those networks, including them in their VPN network. So now everyone who buys their service can route their traffic through your company's network. Convenient, right? And this business model is actually quite successful because all of the other APTs that I just showed you, all the hacker groups, they need this sort of thing to hide where they're actually coming from. So then again, that's another motivation for the hacker groups. Moving on, we have watering hole attacks. Watering hole attacks involves using some innocent company's website that the hacker group has been able to compromise to serve exploits and attacks to your users. Why do they do this? Yes, because maybe they want to include them in their VPN service, or maybe they just want to build a botnet that they can use to sell as a service. Well, if your website were to be compromised by one of these hacker groups, the way the attack would work is that the attacker would plant an exploit kit on your web server. Next time you visit that website, your browser will get served the exploit kit, and if you're vulnerable to it, your computer would be compromised. Now the attacker can control your computer. And many attacks in the media have been done using this methodology. And all the time in Norway and other countries, websites are hacked and serving exploits like this. One example that I pulled off the internet just before this talk is a Norwegian website that has been hacked for months. We have notified them, of course, but they either don't want to or don't have the ability to deal with it. So what has happened here is that some hacker group, apparently supporting some political agenda, has hacked the website, serving their content, and possibly serving an exploit kit as well, infecting more users. So I just want to show you this to let you see what we are sort of up against here. So who can do this? Well, the former hacker groups that I mentioned, but also just kids sitting in a room using a scanner looking for vulnerabilities may be able to exploit a vulnerability in your website and do something like this to you. And that's not cool. Also, politically motivated hackers, as we see here, are able and are doing these sorts of attacks. So, how do they do it? I mean, we have Antivirus, right? This is to stop this. And you're in the cloud, which means you're always patched. You think you're secure. So, what the attacker wants to achieve is total control of your computer. My computer like this, they want to get root access or system level access on that computer. So, as I said, they use exploit kits. And these exploit kits is just a collection of attacks. Every time a hacker group finds a new vulnerability, or some vulnerability gets publicly known through, say, a Microsoft bulletin, which comes out every month, they try to develop exploit code to make or to take use of one of those vulnerabilities. And they include them in their exploit kits, which they again plant on their websites, just snowballing the problem on. So, most exploit kits, as you may be aware, are targeting Windows. And the reason for that is of course simply that Windows is the most prevalent operating system out there. There are, of course, exploit kits targeting Mac and Linux as well, but they're very rare in comparison to Windows exploit kits. And the vectors that they use is often unpatched Internet Explorers. There's all these extensions to your browser that they can exploit. So when you come visiting that website that was just infected, and you haven't patched your Java, they can make use of that to take over your computers in some cases. Also, there are what is known as zero days. Problems or vulnerabilities that haven't been made public yet. And there are some groups that are employing those, but they have become so rare that they are too costly and valuable to be using in this sort of attacks. So the best advice, of course, is to make sure everything you have is patched, especially browsers, because that's the most attractive attack surface to an attacker. Okay, here's a bit of an uncomfortable fact that I want you to see. Antivirus does not stop all attacks. The way antivirus works today is that it's operating on a database of signatures. It has a list of all these signatures of known malware. And what is known, it can stop most of the time. These lists are updated usually daily, which means that a lot of the malware out there that's operating is on the list. But it's shockingly easy for an attacker to generate a new exploit or attack code that is actually not on the list yet. That's possible because, you're all coders, you can change small details in your code and the signature will change along with it. If you take the MD5 hash of your executable and then you change something, it's going to be totally different the next time. So that's why antivirus has some issues. The next uncomfortable fact is that your users are not always patched. That's you can see it in your browser statistics. There are still people using Internet Explorer 6, and 7, and 8, and Java that isn't patched, and Flash, and Adobe, the list goes on. So, why am I telling you this? The reason that these attacks occur is because websites are vulnerable in the first place, right? They can use some vulnerability in the website to host their exploit code on there. So we need to make sure that our websites are so secure that they can't easily be compromised this way, protecting our users. So, isn't that the IT department's problem? No, it isn't. We have a responsibility as developers as well. I'm going to show you a little demo if everything goes well. about how an attack like this can be executed. So please bear with me, this may cause some technical difficulties, but we'll see. I'm just gonna have to change screens. There we go. Oops. Okay, can you see it as well? I'll zoom in a little bit if you can't see it. Okay, so this website right here, a lot of you at SuperOffice have seen it before because you have been training and finding vulnerabilities and exploiting them in this website. This is a web shop that's made to be pretty vulnerable. And one of the vulnerabilities I want to show you is a Crosssite scripting vulnerability. How many people in here are familiar with Crosssite scripting vulnerabilities? A lot, that's good. Are you familiar with the consequences of Crosssite scripting vulnerabilities? What is the worst an attacker can do with a Crosssite scripting vulnerability?
Get access to your database.
Your database? I think you're mixing it up with SQL Injection.
Oh, yes.
Maybe?
Steal a session token?
Yeah, that's the most, that's the common belief. You can steal a session token, and that's true. You can steal a session token if the developer forgot to put the HTTP only flag on the cookies, right? But there are other things you can do, right? Because you can, with a cross-site scripting vulnerability, you are able to inject both HTML code and JavaScript code onto the website. So if we take a look at this page, there's a field right here. I'm gonna try to inject something right here. Just do a simple script, alert one and script. Okay, you all know what this is gonna do, right? So, yeah, there we go. It pops up the alert box, and right here I can dump the session token of a logged in user next to visiting the website, stealing his session. That's bad, but most people have implemented protections against this sort of attack. So, what I want to do is attack the users of this site, because I know there's a user visiting this website. His name's Chell, by the way. Sorry. And I know that he likes to browse exclusive sofa sections. He's in the market to buy one. So I'm gonna go into my terminal here, because you all like terminals, right?
Oh yeah.
So what this is the Metasploit framework. It's a tool that is used by both professional penetration testers, security researchers, and also attackers. And in this tool, there is a lot of exploits, as you can see here. These are attack code exploits. So what I'm going to do, I'm going to load up an attack that some of you may be familiar with. It's sort of an old attack, but I know that Shell is using a pretty old browser. So I'm going to target this user. Okay, so this script is going to load some settings for this exploit. And I'm ready to go. Okay. All I do is type exploit --j. And we have an attack server running on my computer at port 80/expanding world. Okay, the next thing I'm going to do, I need to make sure that the user visits my link somehow. And since I know that Shell is visiting this web shop, browsing for exclusive sofa sections, I may leave a malicious comment right here. I prepared this in advance, and this is just an iframe that includes my malicious URL. It's not going to be showing because I've told it to not display on the page. So hopefully the comment will be invisible. So let's add this comment and quickly browse to our attack server looking for incoming connections. Okay, you see the first one here is a visit from myself. So I'm not vulnerable with this browser, so nothing's gonna happen. But if all goes according to plan, Shell might visit the website. And here we see another IP visiting. We see that the program is sending stage. That means it's loading the rest of the attack code over the network. And the interpreter session 1 opened. That means now, if I do sessions I1, have a shell on Shell's machine. I am in control of Shell's machine right now. So I'm just gonna do this really quickly, shut down my attack server, because I don't want any other users to be hacked by that. And then I'm gonna start interacting with my shell again. And let me give you just a small, short brief on what happened just now. The exploit is targeting the Internet Explorer browser, an old version, because he hasn't patched. And once that exploit code is run, I get control of the execution flow of the process, of the Internet Explorer process, which means I can tell the Internet Explorer process to do pretty much anything I like. The next thing I ask the attacker to do is migrate my attack from the Internet Explorer process into another process. Because I know that maybe Shell will close his browser and I'm gone. I don't want that. I want to stay in that machine. So if I do a PS now, I can list all the processes on Shell's machine. Let's see if we can do this a little bigger.
Sorry, this all happened just because you went onto the site?
Yes.
And that's it, you didn't click anything?
He didn't click anything because when he visited this site,
It was only loaded your comment.
the comment is loaded in the source code. Let's see if I can show you. Iframe. There it is. There's a hidden iframe in here, loading JavaScript from my server. And that JavaScript contains the exploit actually exploiting the process. And so now I have control over the system as Shell. But what else do I want to do? I want to get full system access, right? Because Shell may be just a regular user on the system. So this shell I am on has some features built into it. If I type get system, I can actually get system. This is a very old installation. He's running an old operating system, and this technique is very simple to do on this operating system. So now I have full control of this computer as the system user, and he can do anything, right? Okay, so what else do we want to do on Shell's computer? We may want to see if there are any other users on there. And if we list all the processes running, there are a lot of Python CMD here. And all of these, if you look at this column, this tells us which user is running the process, right? So, oh, here we see there's another user on there, Lynn. And there's also this one, Bucket. So, imagine that this computer is in your company's network. Now I can access all internal services on that network. That's bad, right? But I can't really hop to another machine without knowing anybody else's password, because Shell only has access to his computer. But maybe these other people have access to other computers in the network. So let's try to get their password. And I'm gonna have a prepared command for this. Let's see if I can just bring it up. So the next thing that happens is I am telling the interpreter, my shell, oops, sorry, just need to do some maintenance first. load Mimikatz. And Mimikatz is a software developed by a French man called Benjamin Delpy. And he made that, he's a security researcher, to prove that on Windows systems, passwords are cached in memory. And that's a known problem, because when you log into a Windows box under a domain, the password has to remain or stick around in memory so that you can use single sign-on to your file share, you can use single sign-on to your Exchange server, all these things. So these passwords that for Chell and Wakke and all the other users logged onto the system, they remain in memory. And this little extension is going to try to pull them out of memory, search for them, and dump them to us. So by running this command, we end up with some passwords. And there we are. Now we can use these passwords to try to pivot off of this box, use it as a hot point, and try to log into other machines on your network. And this is scary because now we can try to exploit your development server or your, let's say, your source code repository, trying to get your source code for your partner application, injecting something malicious into that. So all of this is just to show you the consequence of a single cross-site scripting vulnerability may lead to a user actually getting compromised like this. And that is why we need to take some steps to make sure that cross-site vulnerabilities aren't very common in our software. So I'm going to hop back to the presentation. Let's see. Bear with me, please. Screens. Okay, so most users aren't using this old browser on this old operating system anymore, so why should we care? I mean, most people won't get exploited like that, right? That's what you all think. Or if you look at these lists, these are from the Metasploit framework, and these are exploit code, each module targeting one piece of software for all kinds of new and old browsers. You can see over here that these are Microsoft bulletins. This is 2014, 2013, and if you browse the list even further, there's some for 2015. So this happens all the time, and we need to be prepared for that. So our web applications, as I've shown you, is often used for serving these sort of exploit kits. Also, they're used as entry points directly without attacking the users into your application. As you mentioned, SQL injections, for instance. That's a big concern there. The value for the attacker is that he gets either access to your users' computers, or he gets directly access to your data in the web applications, right? So, one of the things I want you to know about, and that Margareta has mentioned earlier today as well, is the Open Web Application Security Project. This is an amazing resource for materials that you can use when you're developing. Look up best practices for how to implement common features like authentication and authorization. Also, you can look up testing methodologies on how to test your software. We use this a lot in our security testing, on how to test your software for these vulnerabilities. If you want to test for SQL injection, what do you do? If you want to find all your cross-site scriptings, what do you do? And how do you avoid it? I'm getting to that. So every 2 or 3 years, OWASP gives out the top 10 list of the most common web application vulnerability categories. And this looks something like this. This is the 2013 version. And you can see on the top is injection attacks. And that's, as you said, SQL injection is actually still one of the most common vectors for attackers. But on a third place, cross-site scripting is also. Number 2, broken authentication and session management. That includes the use of weak passwords. It includes missing HTTP only flags on cookies so that you can steal them via cross-site scripting attacks. All of these things are bundled into these categories, showing you what is most common and what you need to be thinking about when writing your code. So, why is this so hard? Why do we still have these web vulnerabilities after making applications for 20, 25 years, even more maybe? The main reasons are web applications are using such a wide range of technologies. They're always evolving, we're always using new stuff, new JavaScript libraries, new .NET modules. All of these may contain flaws. And also when you write the code, you may not be 100% familiar with all the security functionality built into these modules, and you may end up introducing vulnerabilities yourself. The next point is the time to market and cost point, which is, well, it's a very big driver for introducing security vulnerabilities, because your boss says that he needs this by Monday, and, well, that doesn't leave time to make it secure. Doesn't leave time for you to think about all the attack vectors that may apply to your code. And also, there is lack of training. We hope to address this somewhat and make you more aware with talks like this, that maybe we can avoid having these sort of problems in the future. And also, we all to some degree have to deal with legacy technology that it's very hard to implement good security measures in. And systems that are running on all platforms just because that's the only place they can run, right? So what can we do about this? Well, we can employ new technologies that browsers and technologies like .NET and new JavaScript frameworks are implementing. So content security policy is a new feature in browsers that can be used to eliminate one of the OWASP top 10 categories that I just showed, cross-site scripting. How many is familiar with this, with content security policy? 2? Okay, so what it is, it lets your web application declare to every web browser or every user that visits the site which resources are allowed to load from your page. As you saw earlier, I injected JavaScript into a web shop, and the JavaScript was loaded from my domain, which could be named evilsite.com, right? What content security policy can do is that it lets you define beforehand what domains are we allowed to load JavaScript from. You with me? If we do that, we can we can reduce the impact of cross-site scripting vulnerabilities considerably, because it leaves the attacker less wiggle room. He may not even be able to inject anything at all because your policy does not allow it. So all this is, in practice, is an HTTP header that says your site is allowed to load scripts from Google, maybe it's allowed to load scripts from your domain, maybe some subdomains, maybe from SuperOffice. But you can declare it all beforehand and making it all a bit more predictable. So this means that we sort of offloading the responsibility of detecting attacks to the browser, and all modern browsers, I will show you a slide later on, support this. So it shouldn't be a problem for you to start thinking about implementing this. I'll show you a little bit of a demo on how this works in practice. I'm just going to change this place again. So let's try this. Okay. So this simple website, let me just remove this. Yeah, it takes the name, as you can see, as a parameter and outputs it in the HTML. So what you as a developer should be testing is, can I inject something here? Can I add my script tag to the name? Let's see, true, one and script. And yes, we can. So this is the same vulnerability we saw earlier. Simple vulnerability, attackers will find it and use it. So, if we introduce content security policy, what will happen? Let's see, example 2. I'm going to try to use the same string, like this. Oh, it's not the same string, but it should have the same effect. It should launch the alert box. But this time, it was blocked. If we open up Firebug, let's see what the browser is telling us here. Just going to reload the page. And now it says, I don't know if you can read this, it says the content security policy, the page's settings block the loading of a resource at self. So the policy of this website says that JavaScript cannot even be loaded in line. You can't put JavaScript directly in HTML code. You can only load it via script tags in the head of the HTML document. So this effectively blocks this attack. And this is just by setting a simple header on your web server. So I think you guys should be thinking about doing this. Let me show you how the header looks. Let's see. This, I think. Okay. There we go. Can you read it? No? It says content security policy, default minus source, self. That's all it takes. So this is a simple security mechanism that you can implement right away that will give you a lot of benefit, in my opinion. And so, even though you have users using relatively old browsers, which they shouldn't, of course, most modern browsers should be supporting this. So, how many is going to use this in their next web application? Thank you. The next thing I'm going to talk about is web application firewalls. This is another security measure that you should be familiar with, and that or know exists at least, that you can use to protect your own web applications. So the reason why you want to use one is you want to know what happens to your web application when they go live on the internet. That's why you have monitoring, right? And that's why you look at your logs. A web application firewall will produce logs of what attacks hit your web application and from where. So that information is quite valuable to you because you now know what attacks are the bad guys out there trying to do to my servers, and do they have any chance of succeeding? Did I think of that attack? So by deploying a web application firewall, and you can do it in many ways. You can do it as a proxy in front of your web server, or you can do it as a proxy on your web server. They will detect, and if you tell them to, even try to block attacks. So if for instance, if your application crashes with a 500 error code, you may want to look into it, right? If you can correlate that crash to an attack at the same time, then you know you may have a problem. So this is a good source for information about which attacks are hitting me, what do I need to improve in my application. And also, if you see a lot of Chinese IPs trying to visit your new partner application, you may, if you don't have many customers or expect many customers in China, you may want to look into that, right? And a web application may be able to tell you that, okay, these Chinese IPs are attacking me. Probably someone using that VPN service from earlier, right? So let's block them. Some of the alternatives that can be used for web application firewalls is mod security. It's an open source application. You can run it on both IIS and Apache. I would recommend checking it out. It has a set of rules from OWASP that they made based on the top 10 categories and all the other vulnerabilities that they know about. And there are also many good commercial options. You can even buy it as a cloud service where you proxy your traffic through a cloud of a provider, and they will try to block and detect attacks for you, which could be useful. Also, I would urge you to fuss and test your applications as a developer. You probably do this to some degree, but how many of you, well, do fuss testing of your applications with regards to input? Some? Yeah? Because this will show not only security errors, but functional errors as well, right? It takes time, but it may prevent some serious vulnerabilities in your code. A penetration test of a web application will certainly do this sort of activity. So if you haven't prepared for it, it may yield some surprising results. I would like to recommend a simple directory fusser that you can use. It's called Deerbuster. It is available online. OWASP has made a GUI for it, which is called, I think it's called the same thing, OWASP Deerbuster. What it does is it's fuzzing directories, looking for directories on your server. And I think you as developers should be doing this after you deploy a product, just to make sure that that .git file didn't make it onto the production server, revealing all of your files, all of the files from your project, or that your web config isn't accessible for everyone to see. So this is what the output looks like from this fuzzer. It's just going to be, you're going to give it a word list. It's going to look through all of these words and extensions if you want to, checking to see if those files are there. And there are good word lists out there in Kali Linux that I just used for the demo as a distribution. But also in OWASP, you'll find these sort of word lists that you can use to fuss your own servers and applications, looking for things that shouldn't be there. And it'll return, as you see, the code, the response code of the file you're looking for. So we can see here that php.info.php. Okay, it didn't give anything, but it found a 302. So maybe there's something there. PHP INI, maybe not a good sign. Also, fuss testing may involve testing for SQL injection. And as I hope all of you know, you should be using prepared statements or some sort of object layer between your database and your application. If you haven't, I urge you to search your source code for statements not using these prepared statements. If you find them, you can try to fuss them using tools like SQL map, to try to reveal SQL vulnerabilities, SQL injection vulnerabilities. Because these vulnerabilities will not only give an attacker access to your whole database, but it may also make it possible for him to get a shell, just like I did, compromise the whole server by using one of SQL injection. So beware of that. It's still on the number one for OWASP. HTTPS. SuperOffice has made it a requirement that partner applications are speaking HTTPS to the APIs. And there's a reason for that. HTTPS is very important. Your traffic travels the internet across all the gateways and all the routers. If it does that in clear text, someone may or may not find sensitive information in that traffic. Imagine if your customers are on a train using an insecure wireless network and your application doesn't use HTTPS. How easy is it for an attacker to just sniff that traffic, take some passwords, log into your service? it should be obvious by now that we have to use HTTPS everywhere if possible. Even internally, if you have internal applications, I would recommend you to put on HTTPS and deploy some sort of internal certificate scheme or even buy certificates for your internal services. And remember that HTTPS is using cryptography and also software. And software has flaws, which means it needs to be patched every once in a while. In the past year, there has been two very serious vulnerabilities. We have Heartbleed, which some of you may be familiar with. It allowed you to dump the memory contents of vulnerable servers, and the memory contents may contain usernames and passwords to services, or it may contain your certificate private key, which means that the attacker could spoof your site, pretend that they're you. Also, there's a vulnerability called Poodle, which is a padding oracle attack that lets anyone sniffing your traffic more easily decrypt it afterwards. So if I catch your traffic, because you're surfing on the hotel Wi-Fi, I can later go home and I can try to crack that encrypted traffic, extracting your usernames and passwords again. So make sure that you configure the HTTPS and use this service actively to try to achieve an A. Because that means your certificate is valid, your protocols are in order, and that you're supporting the right protocols, deactivating the old ones, and that the ciphers that are used in encryption is strong enough so that if I rent a data center, I still can't crack that key and decrypt your traffic. So how do you do that on your servers? There's a PowerShell script out that the National Security Authority has written, and they have a guide on how to use it. If you go to this URL, maybe we can publish just slides after.
Yeah.
And you can download this zip file containing some PowerShell, PDF of how and what you're doing and why you're doing it. And you can just run that PowerShell on your Windows servers in order to configure your HTTPS configuration. And it's going to deactivate SSL 2, 3, and it's going to enable SSL 1.1 and then 1.2. So it's going to do a lot of good for your servers, and it's quite simple to use. So, it doesn't really matter if you have secured your web application very, very well, unless you harden your server. Because when your web application is deployed to the online environment that you're putting it in, you need to be doing server hardening. That means removing those configuration files that used to be world readable in the development environment. It means turning off those ugly stack traces so that the application doesn't leak sensitive information through it, and doing all of these steps before every deployment. And here's some steps that you can keep in mind. Remove test users, for instance. You don't want test users following you into production often, right? Because you don't want the attackers to be able to log into your solution and start exploring attack vectors there. Also, I would recommend you to employ antivirus software on servers, and also there's some anti-exploitation software from Microsoft called Emmet that you may want to consider using on servers. I think this would have stopped the attack we just did in a demo, if that was installed on the computer. So I highly recommend that one. And also, finally, I want to tell you that if you're in the cloud and you have administrative websites, you have operation centers and all this, you do want to make sure that not the whole world can log into them, if you can. I know that in most cases we have to allow a lot of IPs from a lot of different places, so it's hard to do this. But if you have an operation center that you're using only internally and that only your company should be able to access, please use IP filtering. Most cloud providers have this option. And this would very much limit your attack surface. Because that would allow only you from your IP range to log in. So, is that it? No, not quite. It's security is a very broad field, and there's a lot of things to think about. But this should help you on the way and get started. Hope you can make use of some of these tips. And, well, yeah, that's about it. Do you have any questions?
How secure is SuperOffice Online?
Courageous. It's a lot more secure than when we first started working with you. No, but seriously, it's online environments are very hard to secure. But if you do all of these things and you do them regularly, you will get to a level where we can be satisfied. Because we can't secure everything 100%, it's impossible, right? So we got to get to the level where we can be sort of satisfied that we can accept the risk. That's a diplomatic answer. Other questions? I have, I'm gonna give out bonds for each question that's asked. There you go. Yeah.
Is Linux in general more secure than Windows? I had two series of attacks where introduced the problem machine and did bad things. Both of them on Linux. Windows servers, rarely, and very small sort of attack.
Okay.
So my experience is that Linux is the worst shit.
No, I wouldn't say Linux is more insecure than Windows, because the reason most attacks in media are on Windows platforms, it's because most users are using Windows, right? So malware writers and attackers are targeting the platforms that have the most users. It just makes sense. That you have had attacks on Linux doesn't surprise me, but because configuring Linux is hard. There's a lot of options, and it's well, you got to do more to protect yourself maybe than on Windows. Did it answer your question? Sir? Other questions?
Is there any way we can get like a sample report, not obviously with company names, but an idea of what we've done and gives ideas of what we need to...
Oh, sample reports?
Yeah, that you've done for other people, like in SuperOffice apps.
Yeah, why don't we just tell you everything that's open?
Obviously not. The other things to watch out for, things that we need to work through before you guys come in and rip us apart.
We may be able to produce something like that, yeah.
Yeah.
It's a good idea. Definitely. To make sort of a short list of the things we have seen so far and distribute it to partners, maybe a good idea. Anyone else? Questions?
Can I have a ball?
Good question. You didn't get one. Oh, you got one? Okay. There you go. Oh, you didn't get one. Okay, so
I have one. So
yeah.
how long does a security audit take when security?
How long does it take? As you think about the partner audit, right?
Yeah.
We have been scheduling 2 days for doing one, but of course there are sometimes delays and back and forth that take more time. But should be able to do it when it's totally streamlined and 2 days or less, hopefully less. Yeah. Okay. Thank you. If there's any other questions, you can email me at this address. Thank you.